Hi everyone, welcome to Rescuing Watches. Today is a very exciting day. We get to work on the first Rolex here on the channel, and not just any Rolex. This is a very special Datejust reference 1603 that was earned by an IBM employee after 25 years of work. The dial is absolutely stunning, matte gray with white text and perfectly aged 3D implodes. Here on the case back, we have the IBM Quarter Century Club engraving to Charles W. Jansen, June 2nd, 1977. So this was for sure a very significant watch in his life and certainly one of the coolest vintage references out there. Let's have a look. Well, to start with, the pendant tube seems worn down, which makes the crown pop out right away. The watch was made in 1971 and sold as non-running, but let's double check because you never know. No luck. So let's open it up and see if we can find the reason it's broken and fix it. In case this is your first time on the channel, welcome. My name is Ignacy. I'm a watch repair hobbyist, and Rescuing Watches is about taking beautiful vintage watches that have been left behind and try to bring them back to life so they can be enjoyed for many more years. Usually learning as we go, sometimes more successfully than others, but we're getting there. Let's finish with a rubber ball, and this is where it starts to get interesting. Let's see what we got. Okay, not bad. We can see the engraving on the inside of the case back. Let's see, Montreux Rolex SA, Geneva, Switzerland, and in red we have a watchmaker mark. The movement looks like it needs a cleaning, but still beautiful, especially the automatic bridge with that golden engraving. This is a caliber 1570 that was in production from 1965 until the late 70s. And looking here under the microscope, we can see a bunch of dirt buildup on the stem. Not a good sign. Anyway, so why do we have a Rolex with an IBM engraving on the case back? I was asking myself the same question. IBM is a huge tech company. They were pioneering data storage technology in the 70s. They invented the first commercial hard drive and floppy disks, and they were just making tons of computers during the 80s. So it turns out that if you were an employee there for 25 years, they would organize a big lunch, and one of the presents they would give you was an engraved Rolex Datejust. So pretty cool. I was looking through watch forums, and IBM did that until the early 90s. Then it changed to a Tudor watch, and I couldn't find out if they still give something these days, but I hope they still do. And here it is. This is what we watch nerds call a Paipan Sigma dial. The Paipan refers to that recessed outer edge that gives the dial a bit more depth. And before we get into Sigma dials, let me check that seconds hand for a second because it has some, I don't know, some kind of, I thought it was rust at first, but it looks like some kind of grease or resin. And here underneath you can see the Sigma symbols on the outside of the T Swiss T writing. The T means that the lume used on the watch is tritium based and not radium as with the older models. I'm a bit worried though about that seconds hand. I'm always amazed by these things. How is something like this even getting there? And why is it only on top of the seconds hand? I have absolutely no idea, but in my mind, this can only happen if someone is manipulating the hands, so let's hope we don't find more of it inside the movement. Let's unscrew the dial fit screws and back to the Greek Sigma letters on the dial. These symbols were not exclusive to Rolex. You can also find them in other brands like Patek, Omega or IWC, and they indicate that the hour markers on the hands are made of gold. That was an initiative from the Swiss Association for the Industrial Promotion of Gold in the 70s, and their goal was to encourage the use of gold in watches, basically to protect the Swiss gold industry and also to position Swiss mechanical watches as luxury items, especially steel models, because at the time quartz watches were on the rise. The dial is out, and we can see a mark on the back as well. Unfortunately, these marks are specific to each watchmaker, so they can refer back to their notebook if they service this watch again and check what they did the first time. So no clue what they mean. We can turn the movement around to start the disassembly with the automatic mechanism. The Sigma initiative didn't last long, I think just about a decade. Rolex only used it for a handful of years, so these days it's just a quirk that collectors like, and as it's usually the case with these things, it does increase a bit the value of the watch. The automatic bridge is now free. Let's set it aside and take a look at the heart of the watch. Oh wow. Very nice finishing, to be honest, for such a high production movement. The 1570 was one of the most popular calibers that Rolex produced at the time. I think they were making close to 500,000 of these per year and fitting them into iconic references like the Submariner 5512 or the Explorer 1016. And it's actually a chronometer certified caliber, which means that it's a very, very accurate movement when it runs. Okay, let's go under the microscope and check if the pallet fork bounces back and forth. And it doesn't, which means that either there's no power on the mainspring or something is stuck. And a small sign of attention to detail here by the brand, look how nicely polished the pallet fork is and the anglage on the edges. After the balance is out of the way, I like to turn again to the calendar mechanism. The first thing that comes out here is the date wheel, using plastic tweezers so we don't damage the black paint. Now this outer ring here is the date indicator sitting, which allows the date wheel to sit slightly above the rest of the parts and spin freely. This caliber does not have a quick set date mechanism, so we can't change the date independently, but it has what Rolex described as an instantaneous date mechanism, which makes the date wheel change extremely fast. This is achieved with a very interesting mechanism invented in the 50s by a Rolex engineer named Mark Huguenot. There are a few components that make this work. We have this massive spring that I'm holding with a bit of pegwood, along with the wheel that we just unscrewed. Here it is, and built underneath you can see a cam mechanism. The hour wheel goes out. It has a bit of grease underneath. And this is how the date setting mechanism looks in the patent. So we have the pink switch finger and the purple cam built into the wheel that we just removed. And then we have a green yoke that pushes against the cam, which is this part here. Let me try to... Oh, of course, it was held by a spring and just flew away. Fortunately, not too far. Here is the yoke. And there's the jewel. There you go. So just to explain how it works in a few words, when the cam underneath the wheel contacts the yoke around late evening, it starts building quite a bit of tension against this big spring here. And because of the cam shape at 12 o'clock, all the tension is suddenly released. The switch finger hits the date wheel pretty hard and makes it spin to the next number. Because of the strength of the spring, the date wheel spins so fast that it looks like the numbers just appear out of nothing. That's why Rolex describes it as instantaneous. Here on this side, we only have the keyless works left. That's the mechanism that allows us to set the crown in different positions to wind up the watch or to set the time. I haven't seen anything broken yet. This is the minute wheel. And you can see the perlage finishing on the main plate while we remove the yoke spring. Perlage refers to these small overlapping circles done by hand using semi-automatic machines which have a spinning rod that operates the movement. All this is hidden under a solid caseback, so it's a sign of quality if they still took the time to do it. The cannon pinion is out, quite greasy as well. And now we can just continue with the other side of the movement. Another sign of quality is having a shock protection system for the escape wheel, which is not that common and helps a lot since that wheel has the thinnest pivots along with the pallet fork, which is stuck to its bridge. Lots of parts stuck to each other. This little brass spring here is called the second pinion friction spring, and it holds down this little guy. That's the center second pinion, which is where the second hand is inserted on the other side of the movement. Engaging with it, we have the driving wheel. This one is pressure fitted to a pivot underneath the bridge, so we use this Presto tool to remove it without bending it. Okay. Well, not pretty, but it worked. Here it is. Oh, did you hear that? That was the mainspring uncoiling inside the barrel once I moved the click aside, which means that there was still a bit of power left in it. In a healthy movement, that leftover power would have made the pallet fork bounce back and forth, but when we checked under the microscope, that was not the case. That means we have an issue somewhere in the train of wheels because that power wasn't making it all the way down to the escapement. That's the click spring. And now we can take out the crown wheel, which you can see it has a separate outer ring with the teeth. That's the only thing that spins, and the rest is fixed in place with these two screws on the center disc. This design makes the winding smoother than having a full wheel spinning. Nothing else to take out on top of the barrel bridge, so we can remove it. Here it is. And we can see a bit of black grease around the barrel arbor hole that's most likely coming out of the mainspring. These days, lubricants are way better and you could service a modern watch after 10 years, but in the 70s it was not the same. Servicing every 3 to 5 years was the norm. The train of wheels bridge is out, and now we can start with the center wheel. Was that where the problem was? That should have come without any effort, and it could very well be the reason why the watch was not working. Escape wheel is out, and this is the barrel with a mainspring inside, but let's leave it aside for now and take out this brass part here, which is the hacking mechanism. Another sign of a higher quality movement, that part moves back and forth to stop the balance when you are setting the time, so it can be done precisely. It's very common these days, but not so much in the early 70s with non-military watches. The setting lever fell from the other side of the movement, and this case screw, and that's it. A really nice movement. You can tell why Rolex was so popular and still is by far the most successful watch brand, at least in terms of sales numbers. And these days is also popular for different reasons, but in the 70s, Rolex popularity was based on their movements and the high quality case construction. I'd say totally justified. And one of the coolest parts on all Rolex movements are those red wheels you can see poking out, but to get there we have to take out the lower bridge. Here it is, with yet another part stuck in the jewel. This brass wheel is the one that engages with the ratchet wheel, and this one here goes in the middle. If you're wondering why are these two wheels red, that's because they have a surface treatment. They're coated with Teflon to reduce friction and wear. These are the wheels that transmit the movement from the oscillating weight to the mainspring, so they need to run very smoothly, and apparently Teflon is self-lubricating, which reduces wear and extends the service life. Now, to separate the oscillating weight from the bridge, we have to take out this spring. You can see the build-up dirt around the rotor's pivot. We'll need to give this a good cleaning. And now it should, there you go. It comes out of the bridge, which has a very nice sunburst finish. The last thing to take apart is the mainspring, which is sitting here coiled up inside the barrel. Okay. We can see more of this, I guess, braking grease residue under the lid and basically all over the mainspring. Here's the barrel arbor in the middle. And now to take this out safely, we alternate between the thumbs and slowly let the mainspring uncoil out of the barrel. Oops. The end is always tricky, not the first time this happens. Replacing the mainspring is always recommended in every service because it loses tension over time. Ours is not even laying flat, so we'll have to get a new one. Now this Datejust reference has an engine turn bezel securing the crystal, so we need to separate it from the case. This is a bezel removal tool with 4 wedges going in between the bezel and the case, very useful to avoid bending anything, especially because these bezels tend to get stuck in place over time. Let's see. Oh no. That's what I was fearing. I'm not sure if you saw that, but it looks like we might have a bunch of rust in between. Oh yeah, quite a lot of rust. And by the color, I would say that it might have eaten a bit of the steel already. We'll see. We can now remove the crystal, which has some dents and scratches here and there, but hopefully we'll be able to keep it. Now, before we deal with the rust, let's remove the pendant tube, starting with the rubber gasket. Rolex pendant tubes have some kind of grooves on the inside, those are called splines. Same thing as the tool we use to remove them, and it makes it easier to grab on and unscrew. But in this case, I can't feel any resistance, so either the splines are worn down or it's a replacement tube that didn't have them. In any case, we can use a pair of pliers to try to grab it and unscrew it. Oh no. Maybe I can still save it. Well, that was not what I had in mind. Oh no. The pendant tube just broke in two, and now we have a worse problem than the rust. There's no way to unscrew it anymore, so the only thing that comes to mind is to take a reamer and try to slowly shave the metal on the inside until we reach the screw threads on the case. Let me take out this big piece first. Okay. I should have heated up the case first. The thing is that these tubes are usually glued in place. You use a soft glue so that it's easy to remove when replacing it, but this one might have been too stuck, and squeezing it with a pliers certainly didn't help. Let's see if we can save it now. I'll go slowly because if I shave off the screw threads, we'll be in serious trouble. Let's check under the microscope. Okay, so we can see the case threads on the bottom, and above that we have the remaining metal from the pendant tube. See that blue material there? That's the glue that is keeping those two stuck together. So shaving more metal seems too risky at this point. I'm afraid of damaging the case. Let's first remove the rust with some pegwood, put the whole thing in the ultrasonic with heated water for a while, and see if we can dissolve the glue. If that doesn't work, then we can think about a plan B, but if we shave those threads too much, the new tube won't screw, and then the case is toast. The more superficial rust seems to be coming out well, but the deeper one might need to be dissolved. See those darker spots? That's where the problem is. That rust eats the steel away and gets deep into it. I think that's as much as I can remove for now. The crown looks as bad as the crown tube, and here we have a stock rubber gasket. Look at all that dirt. I bet it's the same rubber gasket that came with the watch in the 70s. A bit painful to remove those. Rubber gets hard with time and it's a bit of a nightmare to get it out of here. Some of it came out. Okay. Did I see some glue there? I hope not. Come on. Okay. Whew. Done. We just need to unscrew it from the stem, and yeah, it looks okay. A bit of time in the ultrasonic and it's going to look like new again. Same thing here. The caseback rubber gasket has hardened as well. Let me show you. This used to be soft rubber, and it just kind of dries up with time to the point that we can break it in pieces. Great, the movement and case disassembly are done, and now we just have to refit the balance into the main plate to protect it during the cleaning. Also a good time to check if it spins freely, which it does. Now, since we didn't see anything broken, I'm guessing we'll find some dry oil in the jewels that was preventing the movement from running. Let's have a look. The main plate looks fine. Let's check the train of wheels bridge. Okay. There it is. Here you can see a lot of it. That's the jewel for the fourth wheel. And look at that, even dirtier, the jewel for the third wheel. Let's put everything inside the mesh baskets ready for the watch cleaning machine. Everything except the parts that have paint or loom, of course. That would be the dial, hands, and the date indicator wheel. And now inside the plastic basket. Time to clean everything up. This is an Elma watch cleaning machine made in Germany, and the best way to get parts cleaned. We have 3 jars. This first one has a watch-specific cleaning solvent to dissolve all the remaining oils. Then we have the next 2 jars with a rinsing solvent, and finally a heating chamber to dry everything off. Now, for the case parts, which also includes crown and crystal, we have the ultrasonic bath with a watch-specific detergent, and we'll have those in for 25 to 30 minutes. Perfect. This is the bezel after the cleaning. It looks much better, but we can still see some rust leftovers. There's a couple spots that need deeper cleaning, and same thing here for the case. Most of it looks good, but right at the junction there we still have some work to do. Now, the next step is to use a solvent that's meant to dissolve rust. It's called evapor rust, and what we will do is submerge these two case parts in it and have them soaking overnight. Okay, it's been almost 15 hours at this point, and it seems that it's looking great, to be honest, but let's take them out and check. We can always give another try with pegwood and submerge them for a bit longer. But having a look at them, I don't think that's needed. You can still see the spots where the metal was corroded, but no signs of rust anymore, which is what we're looking for. Awesome. Now, the part that's making me nervous, let's check the pendant tube. Oh, wow. This is looking much, much better. So the ultrasonic helped a lot. We can now see the screw threads. Still a lot of glue inside them though, and we still have a bit of the pendant tube metal here below in the lower thread. To dissolve the glue, we will use acetone. This is quite a strong solvent, so I'm pretty sure a few hours will be enough. We submerge the case, and in the meantime we can continue and start with the movement assembly. I got a new mainspring to install into the barrel with the same dimensions as the original one, of course. This one is from a Swiss company called General Resorts and is one of the biggest mainspring suppliers for the Swiss watch industry. There are still some independent companies manufacturing watch components, but way less than in the 70s, and Rolex played an important part on that. Let's put some braking grease into the barrel on two of the sides so that the end of the mainspring can slide without too much friction. So originally, the Swiss watchmaking industry was established as a kind of decentralized system called établissage. That was in the 18th and 19th century after the religious persecution in France. Wait, just let me make sure that this is... Okay, there you go. So yeah, as I was saying, the Swiss watchmaking hubs like Vallée de Joux, Le Locle, La Chaux-de-Fonds, Saint-Imier, all these places had their inner network of specialized artisans, each of them making a specific part of a watch. So let's say your family was making the watch cases, then you had your neighbor making dials, then there was Philippe down the street making wheels, Antoine on the other side of the village was making, I don't know, the blank movements and so on. So that's what établissage means, and it was the traditional kind of collaborative way of making watches in Switzerland. Okay. The barrel is now fully assembled. Let's check that it's closed correctly. Perfect. And now we can have a look at the shock protection systems. We have two slightly different ones here, but both of them are Kiev springs. To remove this one, we have to carefully push the shoulder with an oiler. There you go. And then we can take the jewel out, clean it, and oil it. These shock protection systems, as the name implies, protect the thinnest pivots, so in this case the ones from the escape wheel and the balance staff from shock. So when the watch receives an impact, the pivots have a bit of room to bounce up and down, so they don't break as easily. It's very important to disassemble and clean them because of the way these are made, with two jewels on top of each other. The solvent from the watch cleaning machine doesn't get all the way through, and often there are residues left. Make sure it's secured. Okay. We clean a bit the top with a piece of Rodico. And you can actually see the oil drop in the middle of the jewel. Perfect. This one here is a bit different. I'm not sure if there are some maybe tighter than others, but they work the same way. Oh. No. That's why you should have another tool close by when touching a spring. Fortunately, they didn't go too far. Finding jewels on the floor is usually not a very successful task for me. I was telling you about the établissage system before because one of the reasons that Rolex became the powerhouse that is today is that it moved away from it towards what's called vertical integration, and it was one of the first brands in doing so. Établissage has many advantages. For example, you didn't have to invest resources in massive production facilities, but it's not great for, let's call it, mass production. So from the 20th century, brands started to prioritize vertical integration with the goal of producing as many components in-house as possible. In the case of Rolex, they basically started acquiring the suppliers they were working with. They bought C.R. Spielmann for their cases, Gay Frere for the bracelets, Boninci for the crowns, and so on. So by the 21st century, the top Swiss brands were making all or almost all of components in-house. And the advantages of that is that you have total control over each component in terms of quality and lead time. You have higher margins because there's less intermediaries, or you can patent in-house developments. These days, everyone talks about in-house movement manufacturing, and that's often a reason to consider a brand as higher quality compared to the ones that source parts from external suppliers like ETA, but it was not always like that. And the reality is that for small or independent brands, it's just not possible to manufacture everything themselves. The barrel bridge is on. Let's check that the hacking mechanism can move freely. Perfect. And now we can start with the train of wheels. The first one is the escape wheel. I have to put it straight. Fourth wheel. Now the third wheel with that extended pivot. And finally, the second wheel that goes all the way through the other side of the movement. Now we can secure everything in place with the train of wheels bridge. This caliber was produced by Rolex. You can see here the engraving, but at the time, not all of it was produced in-house yet. The key springs, the jewels, the mainspring, all of this was still sourced externally. Let me see if this is working well. And you can see now the power going from the barrel to the escape wheel smoothly, which is what we're looking for. And also, don't forget that Rolex had Tudor as a second brand, and still has it, of course. The idea was to keep Tudor as a more affordable option, and the strategy to keep the cost down was sourcing off-the-shelf movements from ETA and fit them into a Rolex case. So it's not so clear to me that costs actually come down once you make everything in-house. We're now lubricating the barrel arbor and the jewels. We use different viscosity oils depending on the speed and torque of each part, and we have to do this on both sides of the movement. Same with the crown wheel. Since it has different parts, we need some lubrication on the wheel seating. We place the wheel on top, lubricate the edge, and then the wheel core in the middle. So basically, in mechanical watches, you want to lubricate all the metal parts that are touching each other, except for the wheel teeth. Only wheel pivots and bearings are lubricated because the actual teeth are designed to roll on each other and not slide. So there is already low friction, and oiling them would cause the oil to spread everywhere. It would become sticky over time and cause wear. Finishing the keyless works on this side, and we have to add a tiny drop of oil where the spring meets the click. And now we can secure it in place. And there you go. Nice contrast with the brass ratchet wheel, and nice finishing as well. We have that sunburst pattern in the crown wheel, the ratchet wheel, and the barrel. It's a very nice movement, really, very enjoyable to work with. I found that as a hobbyist, the better the watch is, the easier to service as well. Parts tend to be more robust, which helps a lot, and you can tell by the quality why vintage Rolex is highly appreciated. In general, seeing how Rolex is approaching the market these days and how hard it is to get anything new, these 60s, 70s, even 80s Datejust are, in my opinion, the best entry point to vintage Rolex. Especially references like 1601 or 1603. You can even get later references if you want a quick set date mechanism. We screw the crown to the stem. No glue needed here. Then we can apply some lubrication as well in the different sections before inserting it inside the movement and continuing with the dial side. Perfect. On this side, we have the rest of the keyless works, the motion works, which are the parts that set the time, and the calendar mechanism. The setting lever screw is on the other side, so we have to flip the movement for a second. And here we use a higher viscosity synthetic grease called 9501. This one is for slow moving parts with high torque, and we have to apply it in quite a lot of places. That high viscosity also prevents it from moving around and ending up somewhere else in the movement over time. The yoke spring goes in. Okay. The keyless works was one of the game changers in watchmaking, invented by the Patek Philippe co-founder Adrian Philippe in the 1840s, and it led to most pocket watches having a functional crown instead of a separate key to wind them. That's where the term keyless works comes from, as in without needing a key. If you get the chance to go to a watch museum, which I can definitely recommend if you're a watch enthusiast, they usually have some pocket watches from the 17th and 18th century, and you'll see that they have a hole on their case back with a square pivot coming out of it. So you actually had a chain with a key at the end of it that would go into that square pivot, and turning clockwise, you would wind the watch. Our keyless works is done. Let me just finish screwing the setting lever spring, and then we'll check if it works correctly. And it does. Perfect. You can see it there changing back and forth. Now, before we continue with the calendar, let's finish the escapement. This is the pallet fork, and we are applying some lubricant in the impulse jewels before putting it back in place. The pivot goes inside its jewel, and the end of the fork goes in between the two banking pins. The pallet fork moves very little, I would say maybe 5 degrees back and forth, so oiling the pivots is not recommended just because there won't be much wear anyway, and actually even a tiny drop of oil would cause a bit of drag and lower the amplitude. We can now wind up our mainspring and check the pallet fork. You see how it bounces back and forth? That's because it's under the tension generated by the mainspring, and that's a cue to know the power is going all the way through the train of wheels until the escapement. We fit the driving wheel in the third wheel extended pivot, and to place it correctly, we need to press it down evenly so we can use the hand setting tool. Perfect. And as we said before, that wheel engages with this center seconds pinion, and the problem is that this pinion is so light and so long that if it's not held in place, in this case by the friction spring, the seconds hand on the other side tends to have a stuttering motion back and forth. We're going to screw this on partially first. Okay, and now we can place the end of the spring gently resting, there you go, on top of the pinion. Then we hold it down with the plastic tool so it doesn't slip and finish tightening it. I'll show you how it looks under the microscope because it looks quite cool, but first we'll install the balance, and for this we put it through a special solvent called B-dip to make sure the hairspring is clean. The hairspring in the 70s was already produced by Rolex, and they've kept improving them until now. They use a patented alloy they've called parachrome, which they say is more stable against temperature changes and magnetic fields. Let's see if it wants to run. Ah, nice. Always the best feeling of the hobby, bringing a beautiful movement like this back to life. And check this out. How cool is this? Let's be a bit more careful with the jewels on top of the balance. I'm using a screwdriver this time, which I don't think is the best tool, but the oilers are a bit too flexible. And now with the jewel oiled, we can place it, close the spring, and we'll also clean and oil the upper setting on the escape wheel. Perfect. Time to see how good it runs on the time grapher. Oh wow, look at that. Running absolutely perfect. We have great amplitude, gaining only 2 to 5 seconds a day and 0.1 of bit error, so can't complain. Back to the dial side. This time we can go ahead with the calendar mechanism, starting with the yoke for the cam. We put a tiny drop of oil on the pivot. Now we can turn it and pass it through the jewel. You can see the escape wheel turning through the hole on the main plate. I usually show the time grapher values with the movement facing upwards, but it's important to check and adjust it to different positions as well. Often you spot problems when you measure it sideways, and that's usually the position that the watch will have when we walk. The date jumper is in place, and now the tricky bit. We have to place back the big spring for the yoke. We fit the longer leg first in between the yoke and the jumper, just like that, and then we force the top inside this milled portion on the main plate, which holds it in place. Perfect. Last piece of the puzzle here is the wheel with the cam underneath, but let's put the hour wheel first. Okay, now. I have to get closer with the loupe and make sure that the yoke underneath is resting against the cam. And I think that's it. Let's screw it in place. This is a bit of a weird screw, but it looks like I can make it work with a regular screwdriver. And that's it. We just have to place the outer seating for the date indicator. It has 2 jewels on top. I'm assuming to hold the date wheel in place and let it slide smoothly at the same time. Okay, the date wheel comes next. Nice sunburst finish as well underneath the paint. And we just have to take the jumper out of the way with the pegwood stick and fit the wheel underneath the jewels. There you go. Time to put back our dial. I absolutely love the gray color and the contrast of the white text and orange lume plots. Rolex made so many variants with these 4-digit Datejust models. You can find confetti dials, linen dials, ghost dials, mosaic dials, all kinds of weird combinations and cool stuff. And even in the similar references, you can find dials made out of stone. Now, if you remember, we had some kind of greasy stuff on the tip of the seconds hand, so we'll dip a Q-tip in ethanol and try to clean it. Just very gently back and forth. Looks like it's dissolving well. A bit stubborn. A bit more. Wait, is that? That's very strange. It looks like exactly where these stains were. The plating has rubbed off. Weird. And now we can see these 2 dark spots on the polished hand. I'm very confused. To start with, whatever stain the hand seemed to have eaten through the metal plating, but the thing is that these hands are supposed to be out of solid gold and not plated, so I really did not expect that to happen. Bit frustrating, but it is what it is. That's part of the hobby. We have to decide what to do, but let me place the hands first and we can see how it looks. We have fiber there. Okay, and now the minute hand goes next. Making sure both hands are centered at 12 o'clock. There you go. Let's check if the calendar turns at midnight. Okay, well, a few minutes before 12, but that's fine. And now we can place the seconds hand. Okay. Gently, because we only have the spring holding the center seconds pinion on the other side. Let's have a look. Well, you can definitely see it if you know the damage is there, but not a huge problem either, so I might leave it as it is. Let's continue for now with the automatic mechanism, starting with these beautiful red reversing wheels. These ones are lubricated a bit differently. We use a special oil called loupe, so we submerge each one in it for 10 seconds, and what this does is coating the wheels in a very thin film of lubricant, so we avoid over-lubricating, which can create a lot of issues here. We blow the excess, and now we let them dry for 15 minutes. I said before that teeth are not usually oiled, but inside these wheels there are a couple of levers that engage with the reversing wheel drivers. I'll show you in a bit, but that needs to run very, very smoothly. So a submersion lubricant works very well, and to be honest, makes the job easier. We place the pinion for the oscillating weight. And now the 2 reversing wheels. If you have a look at the outer metal rings, you will see 2 levers poking out a bit. These levers are engaging with the teeth on the reversing wheel drivers, which are these ones right at the center, and basically allow for bidirectional winding, meaning that they alternate depending on which direction the rotor is spinning, so that the mainspring is always winding. Rolex did not invent the self-winding watch, but they did invent the 360 degrees rotor, and this set of wheels are essential for it to work. Spinning the full 360 degrees made the mechanism much more efficient and kind of set the standard for the rest of the brands. And by the way, the word perpetual in Oyster Perpetual refers to that automatic mechanism. The lower bridge secures both reversing wheels and the driving wheel for the ratchet wheel. And even though we lubricated the reversing wheels before, we still have to put some oil in the pivots, both front and back. You can see some cuts on the metal. That is mainly to make the rotor lighter on that intersection because most of its weight is distributed at the outer edge, so it can spin easier. The automatic mechanism is done, and now back with our main issue. The glue must have been dissolved by now, hopefully, but let's check. And it looks great. The metal remnant of the pendant tube is still there in one of the gaps, but the rest seems clean and free of glue. So I'm going to show you what my plan is. Plan A will be to screw on this pendant tube replacement, even with one of the gaps being covered. And if that doesn't work, we'll change to Plan B, which is this scary looking tool made specifically for threading watch cases. It has very aggressive edges, and the reason that this is Plan B is because I just bought it, I never used it before, and it seems like a pretty bad idea to use it on this watch for the first time. I learned that in watch repair, things don't usually work out well the first try, especially for a hobbyist. And if I do this wrong and damage the screw threads on the case, we will have a very expensive problem. Let's screw the new tube on, this time properly with our tool and not with the pliers, and then we can check how the inside looks under the microscope. That seems all the way in. Oh, nice. That's a relief. It seems that we got lucky and the tube stopped on the thread immediately before the block one. Let's check the other side. Perfect. And now, just so you see it, these dents are the splines I was talking about to screw and unscrew the pendant tube. But now that I saw those under the microscope, I have to admit I think I made a mistake before. The tubes I previously worked with had splines in the inner side and not where these ones are, so probably the adapter I took was too small, and that's why I didn't manage to unscrew it in the first place. Learning one mistake at a time. We put just a bit of soft thread locker glue on the screw thread to make sure it's fixed properly to the case, but also that it can be easily replaced in the future. And now we can screw it one final time inside the case. Awesome. The tube also came with its rubber gasket, and to extend the lifetime and prevent it from cracking, we have to grease it well before putting it inside. Now gently with the tweezers, we can press it in place. There you go. Next we have the crystal that came with the watch. I'm guessing it's the original one, so even if it has some small scratches and dents, I would love to keep it if we manage to make it look right. We're going to fix it to the mat with some Rodico and polish it by hand with Polywatch. I used the Dremel before to polish acrylic crystals, but in this one I'm worried to damage the Cyclops. These ones are a bit of a pain to restore, especially if there are dents on it or just deeper scratches, but let's see what we can do. Okay, it's been already half an hour and I can't feel my fingers anymore, so let's clean it up. Okay, and check how it looks. Pretty good. Nice and shiny, not perfect, not brand new, but I think it might even be nicer that way. and match the watch better. To fix it in place, we have to put the bezel over it. And do you see that pattern on the bezel? That's one of the details of this 1603 reference. That's called an engine turn bezel, as I mentioned before. The rest of the Datejust models have a fluted bezel instead, which is a bit flashier. This one doesn't reflect the light as much. And if you look closely, it has a thicker stripe for every minute, which I think looks awesome. Look at that. Beautiful. Unfortunately, Rolex, doing what Rolex does, discontinued these kinds of bezels in 2016. We greased the gasket and we are closing the case back because we will test the water resistance of the Oyster case. Rolex unveiled the watertight Oyster case in 1926, and the inventive part of this case was not so much the screw-down caseback or the bezel, which was also screwed onto the case in the early Oyster cases. It was actually the crown. The challenge of making watertight watches was that they didn't really know how to properly seal the crown, and what Hans Wilsdorf did, the founder of Rolex, is go through the Swiss patent filings and buying a patent for a screw-down crown from Paul Perregaux and Georges Perret to implement in his watches. Now, there are several ways to test water resistance. This is a pressure tester, and it works by manually building pressure with a lever. In this case, we'll go to 3 bars, which corresponds to 30 meters of water resistance, or close to 100 feet. So now this container is pressurized, and right at the top we have a valve that we can open by pressing it. And if we see a trail of bubbles coming out of the case while we depressurize, it means that we have a leak and water could come inside the case. Okay, a bit more. We can see some bubbles coming out of the lock holes, the crown, and a small one from the bezel as well. But that's completely fine. When there's a leak, you really see a continuous trail of bubbles coming out of that spot. So the pressure test has passed. I've been thinking what to do with the hands, and now that I know what's wrong with the second sand, it's just gonna bother me forever. I also had one more look under the microscope and I saw another of these stains in the hour hand. I have no clue what this is, but I know we might damage the metal if we try to remove it. Part of me also thinks that these hands are made out of steel instead of gold and could have been replaced during a service, otherwise I don't think they would have peeled off. So I had a look around and I found a new set of white gold hands. Well, new to me. The hands are from a 70s Datejust as well, and we're going to use them to replace the stained ones. I got those from a German watch dealer and I saw they had the tritium lume with the exact same shade of the lume plots on the hour markers, so I just couldn't resist. Look how well they match. Finding spare parts for popular models like this is not so hard if you know what you're looking for, and kind of the signs of, relumed hands, repainted dials, and so on. It's not cheap, but I really think it's worth it for a watch like this. We will keep the old ones, of course. I would always recommend to do that, and actually ask them to give you the old parts back when you bring a watch for service. And have a look at this. Absolutely perfect now. Great, really very happy with the change. I just have this thing that when there's something wrong with the watch, that's the only thing I'm looking at, and I just always have it in the back of my mind. But now we can safely move on to the final step, which is fitting the movement inside the case. The first Oyster cases were a bit smaller than this one, 32mm for men and 28mm for women. And back then, in general, especially in the 30s and 40s, the trend was to wear much smaller watches than these days. Actually, in 1945, Rolex launched the Air King line at 34mm, and that was already considered a pretty big watch. The original Datejust size is 36mm for men, like the one we have here, but the new models also come in 41mm. Now we can secure the stem inside the movement. We just have to put it in place and tighten the setting lever screw. And just in case, let's check if the hacking mechanism works correctly. There you go, the balance starts turning once we press the stem in. Now we can place the automatic mechanism sitting on top of the train of wheels bridge and making sure it engages with the ratchet wheel. Everything cleaned and oiled after so many years, and we can finally finish with those blued screws to secure the last part in place. Perfect. We can close the case back again, this time with the movement inside. Not really a good idea to test the water resistance with the movement inside the case, for obvious reasons. And yeah, this is looking really, really great. Wow. We just have to close it up a bit tighter, otherwise it doesn't really seal correctly. And just to be clear, those 3 bars don't mean that you can go diving with a watch like this. More like you can wash your hands and not worry about water coming in. Maybe showering. We won't be putting a leather strap on this watch. I think there's no better way to wear a Datejust than with a Jubilee bracelet. This one has the big crown on the clasp, and it's the Swiss-made version of this bracelet with folded links. I believe this watch would have come with the American version that has solid oval links, and it's a bit sturdier than the Swiss one, to be fair, but those are a lot harder to find. It's a reference 6251H, and this specific one is also from 1971, so same as the rest of the watch. And here it is. A truly quintessential watch, and one that has come back to life and will be enjoyed for many years to come. After all the work that Mr. Jansen put in to get this watch, I think he would be happy with the result. Thank you very much for watching, I hope you enjoyed the journey as well, and see you on the next one.